There are lots of different ways to write the equation of a line. You can actually take one equation for a line and mix it around and come up with a different form, and each form has a specific use. One really common form is the slope-intercept form. Slope-intercept form. You really want to focus on those two words, slope-intercept. The reason it's called slope-intercept form is that the slope and the y-intercept, so where it crosses the y-axis, are given to you directly in this form. So the linear equation y equals mx plus b is written in slope-intercept form. The slope of the line is m, and the y-intercept is b. So for example, you have this equation y equals 2x plus 3. In that case, the slope is 2, and the y-intercept is 3. That means that this graph over to the right crosses the y-axis at 3. So that point right there is 0, 3. And it has a slope of 2. For every unit over you go to the right, you go up 2. So for example, if you were right here, you go over 1, and you over 1, and you go up 2 to 0, 3. So a line is in slope-intercept form if it's in the form y equals mx plus b. There's nothing in front of y besides 1. And b is a constant. When you have an equation in slope-intercept form, it tells you a few things really quickly. So for example, you have the equation y equals negative x plus 2. To put that into full slope-intercept form, you can put a parenthesis around this negative sign. It turns into negative 1. You don't really write the 1 there. And what this tells you at the slope, which is called, we call it m, the slope, m, in this case is going to be the negative 1. So slope is negative 1 here. The y-intercept is going to be right there, so that's 2. Over on the left, you have this equation, and it's not quite in slope-intercept form. You need to do a little work, and the 2 divides into x, and it divides into 3, and it turns into 1/2 x plus 3 over 2. In this case, the 1/2, which is the coefficient of x, is the slope, and the y-intercept is 3 over 2. So having something in slope-intercept form is really helpful because it immediately gives you the slope and the y-intercept of the line. Given an equation, 3x plus y, you might be asked to graph it. So let's try that using slope-intercept form. The first thing you're going to ask yourself, is this in slope-intercept form? It is not, because it needs to be in the form y equals mx plus b. We need to isolate y. Isolate y. We're going to do that by subtracting 3x from both sides. And we end up with y is equal to negative 3x plus 2. And then you can look and compare the general form for slope-intercept and this form. Is it in slope-intercept form? And you can say yes, because it fits the form. There's one coefficient in front of x, and the constant here is all by itself. So you can now say the slope of the line m is negative 3, and the y-intercept is 2. So how would you go about making that graph? Well, a y-intercept of 2 means it passes through the point 0, 2, because the y-intercept is when x is 0. So let's just plot that one point. Let's make that 1, and make that 2. So we know that the y-intercept is 0, 2, right there. Point is 0, 2. And we now know the slope is negative 3, meaning this graph goes down 3 for every 1 it goes over. So if we go 1 over, we know it's going to go down 3. So 1, 2, 3. It's gone down 3. For every 1 it goes over, it goes down 3. So the next point it's going to be at is right there. So now we just connect these two, and here is our graph. We started with the y-intercept, we found a second point, and we connected them. Remember from a couple days ago, all you need is 2 points to define one line. So first you ask yourself, is this in slope-intercept form? If it's not, you put it into slope-intercept form. You identify the slope, you identify the y-intercept, plot the y-intercept, and then you find a second point using the slope. And you can actually tell exactly what this is. You went over 1 from 0, so you're at 1. And you went down 3 from 2, so you're at negative 1. So you can tell a little more. One important thing that slope-intercept form tells you is that if the two lines are parallel. And two different lines in the same plane are parallel if they do not intersect. So we might have a line like this and a line like this. And you can check this really quickly if you're given two lines in slope-intercept form, they have the same slope. Keep in mind, they have to be different lines. If it's not different lines, they're just going to overlap. So in this case, you have two lines here, and they have the same slope. And you know that because they are in slope-intercept form, so slope is right there in front of you. Since these are not the same lines, but they have the same slope, it means they are parallel, which means that they do not intersect. So remember, they have to be different lines, but they have to have the same slope. To recap, a line is in slope-intercept form, an equation is in slope-intercept form, if it has the form y equals mx plus b. M is the slope, and b is the y-intercept, which is where the line crosses the y-axis. You can immediately get the slope and y-intercept of a line if it's in slope-intercept form by identifying the coefficient of x as the slope and the constant as the y-intercept. If you're going to graph an equation using slope-intercept form, the first thing you need to do is make sure it's in slope-intercept form, so y equals mx plus b. And then when it's in slope-intercept form, you identify the slope and the y-intercept, plot 2 points, and connect them. I hope you found this video helpful.